Good afternoon, science students. Welcome to science once again. We are currently working our way through chapter 2 on energy and energy transformations. I'd like for you at this time to open up your science books to page 43 of your science textbook, and then I will have attached to this lesson worksheets 49 and 50 for your notes. If you're in my homeroom, just open up your frog book to page 49 and 50. We're going to pick up where we left off with part 1 of lesson 1, which you watched the other day. And now we are on the second half of lesson 2. And we've been talking about the different types of energy that we have. So we left off talking about these forms of energy, and our notes goes over this one more time. So we're going to look at the idea of potential types of energy. Potential energy is stored energy due to the interactions between objects and particles. And on page 49 of your notes now, you will see these three forms of potential energy. Write this down. I found this on page 43 of our science book. We're going to describe or draw a picture of the example of each form. So our first form, again, is gravitational potential energy. Gravitational potential energy, easy to say. Gravitational, write that word in for your form, and then copy off of the screen the definition. This is stored between an object and Earth, and it depends on the object's weight and height. So the gravitational potential is stored between an object and Earth and depends on the object's weight and height. If I'm going too fast for you, just go ahead and hit pause on the video so you can copy this off the screen. Now you need not only the definition of gravitational, but you need an example. So a good example of gravitational potential would be a skydiver jumping out of an airplane. I believe I did show you that in a previous video of a skydiver jumping out of an airplane. So you can write down, for example, skydiver. Our second form of potential energy then is elastic potential energy. I believe the notes have already written down the word elastic for you. So let's copy the definition. This is energy stored in objects that are compressed or stretched. And again, we could talk about rubber bands, or we can even talk about springs and this kind of energy. It is energy that is compressed or stretched. And then our last form of energy that we talked about in our previous notes is chemical potential energy. Write the word chemical down in the blank for the form on potential energy, and the definition then copy off the screen. Energy that is stored in the chemical bonds between atoms. So for elastic, I forgot to give you an example. An example of that would be a rubber band. And now for chemical potential energy, the example of that would be eating an apple. We see on the screen a glucose molecule, and we know that glucose is a natural sugar that is in most fruits. So eating an apple would give you chemical potential energy. Now at the bottom of the page, our notes wants us to draw a photograph or a picture. And it says, draw a picture of a yo-yo as it moves up and down a string, and label your drawing with these terms. So I want you to actually make two different pictures. Make a yo-yo, and I will put a picture of a yo-yo up on the screen here in a minute. Make a yo-yo that is all wound up, and then show a yo-yo that is, the string is all released. And when it's all wound up, then put the word potential energy next to it. And then when the yo-yo is moving down the string, put the words kinetic energy on it. I'll go ahead and pause the video right now, and you can go ahead and make your drawings there at the bottom of page 49 of your notes. Now let's continue on to page 50, and let's look at the next set of notes, which is found on page 44 of your book. Explain the relationship between work and energy. So let's write down the definition of work. Work is the transfer of energy that occurs when a force is applied over a distance. So copy that off the screen at the top of page 50 of your notes. Work is the transfer of energy that occurs when a force is applied over distance. So if you're pushing a car that is not working down the road, you're transferring energy from your body into moving the car, and you're doing it over some distance. The next section asks for us to classify examples of work. Again, we found this one on page 44 of our book. Circle the examples in which work is occurring. So we know work is occurring if something is being moved. Okay, so that's a key thought. If anything is moving, there is work. So for the first one, lifting a box. Go ahead and circle that. The box is moving, so that is classified as work. The second one, sitting in a car. If you're just sitting there, nothing is happening, so that is not work. So do not circle it. The third one, kicking a ball. Both your leg and the ball is moving, so that would be considered work. Circle it. Sending a text message. Is there anything moving? Yeah, your hand, your fingers, your thumbs. So yes, that would be considered work. Ice skating. There's a lot moving. You know, the legs, the arms, the body, the skates across the ice. So go ahead and circle that. Grocery shopping. Yes, that is work. It's for a lot of work if I go with my wife. Grocery shopping. You got to push the cart. Got to walk up and down the grocery store. You got to pick up things and move them. You put groceries in the cart. You know, walk back out to the car. So a lot of work there. Go ahead and circle grocery shopping. Pushing on a wall. Is there anything moving? No, there isn't. The wall doesn't move. You really don't move. So do not circle that. That is not work. What about thinking? Now, you may think that thinking is work, but it really isn't in this definition on the screen of transferring energy over distance. We're not moving anything when we're just thinking about something. So it is not considered work. Do not circle it. So work depends on both force being applied and distance happening. And so something is going to move. You only do work on an object if that object is moving. So let's look at this example of this girl does work on the box as she lifts it. The work she does transfers energy to the box. So look at the photo on the far left. You can see the box is on the floor. The PE, or the potential energy, is 0. The box does not have any potential energy. It cannot go anywhere sitting on the floor. The W, or work, is at 0 also. There's no work being applied. She's just bent over and touched the box. The second photo you see, now she's lifting the box. The potential energy is coming up because of gravitational potential. There is a possibility she could accidentally drop the box because of gravity. And the work is happening because she's fighting the force of gravity. So you can kind of see the potential and the work are even here. And then on the third photograph, you could see that she's placed the box on the top shelf. Potential energy is at its highest, and the work is at its highest. So the more you're moving that box up, the heavier it is. So anytime we're lifting weights, there is a potential energy because of gravity and work that is being applied for that. So how is energy related to work? is related to work by the motion of the objects from one place to another, like lifting a box, for example. Now let's move on to other forms of energy that you can see on page 50. And write this down. I found this on page 45 of your book. If you'll turn to page 45, you'll actually see this next section that I'm going to put up on the screen on the forms of energy. So we're going to take our time going through these. You will need to know all these for the end of the chapter test. Identify there are 6 forms of energy that you can see here. All right, so the first one is mechanical energy. If you'll read the definition on the screen and then copy this, it is the total energy of an object or a group of objects due to large-scale motions and interactions. Stop right there after interactions. So when I say mechanical energy, I want you to think of parts and pieces of something working together. For example, like a tractor engine. We know a tractor engine has many pieces and parts, and then it moves the wheels of the tractor and the gears of the tractor, and you have this group of objects and large-scale motions. I know when I grew up, my grandfather had a huge steam engine that he would have brought out, and this is the old days when they used to farm a little differently than they do nowadays. And this steam engine had these big wheels that it would have on it, and belts that would come off the steam engine, and it would power different machines with all these groups of objects linked together. Now, there is an example on the screen. The mechanical energy of a basketball increases when a player shoots the basketball. So what are the parts and pieces when you shoot a basketball? Well, in this case, it's the human body. The arms, the wrists, the fingers, the elbow, the legs when you're shooting a jump shot. All of this is part of the mechanical energy of shooting a basketball. Then it says, however, the mechanical energy of a pot of water does not increase when you heat the water. Okay, or there's really no large group of objects here. It's just the water that's in there. So our first form of energy is mechanical energy. Only write down the definition you see in italics print on each of these screens on the different forms of energy. The second form of energy I'd like for us to look at is called sound energy. Write this down, the energy that sound carries. It's right up there on the screen, the energy that sound carries. So when you pluck a guitar string, for example, the string vibrates and produces sound. This vibrating object emits the sound. Now, we talked about this a little bit in our last lesson. Sound energy cannot travel through a vacuum, such as the space between the earth and the sun. So sound needs a medium. We use the word medium, which basically means solid, liquid, or gas to travel through. So when you pluck a guitar string, that's a solid material, then it will vibrate the wood of the guitar. When the wood vibrates, it comes out through the hole of the guitar and then vibrates the air. And then that's how we hear the sound of that music coming to our ears. So I'll try to play some guitar music here for you in this section, and then you can actually see that happening. The third form of energy that I'd like for you to know is the word thermal. I believe you need to write the word thermal in your notes, and then the definition may be there for you. It is the energy due to the motion of particles that make up an object. All objects and materials are made of particles that are always moving. Think about that. Your desk where you're sitting, the atoms, the particles are always moving. We studied this in a previous chapter. Because these particles are moving, they have energy. And thermal energy moves some of these particles from one object, warm object, to a cold object. So when you heat an object, you transfer the thermal energy to those objects from their surroundings. So we've done this experiment before. Take your hand, put it on a cool desk, and when you do that, you can feel the desk slowly warm up. So your thermal energy is being shown. Now, what I may show you here is a camera shot of thermal heat signatures. We are using these kinds of cameras in some of our drones nowadays, and it allows us to see the heat coming off a building, or even in the case of some of the police or firefighters, if someone gets lost and they're lost in the woods or in the field, they can see the heat of the human body in that thermal imagery. You know, the human body is over 98 degrees and the surrounding area is cooler, so you can see the heat of their body. So that is thermal energy due to the motion of the particles that make up an object. Our next form of energy is electric energy. Write this definition down. It is the energy that an electric current carries. Now, an electric fan uses another form of energy. Electric energy, when you turn the fan on, there's electric current that flows through the fan's motor. And the motor has a series of wires and magnets that will cause a turning motion of the motor, and then hooked to the motor is the fan blades, and that causes that to happen. Now, electrical appliances such as fans and dishwashers change electrical energy into other forms of energy. Let me show you a motor. I've got one right here with me. Give you a quick example here. I just thought of this. This is a brand new drone that I've recently purchased, and I'm all kind of zoom in. You can see this is the motor of the drone right here, and this motor has wires inside of it and then some magnets. And so when I apply energy up through this cable from the battery of the drone, it will spin that propeller, and that whole motor will spin with it, and that's what propels a lot of these drones. By the way, this orange drone that you can see here is a brand new one. It's called an Autel Evo 2 drone, and it's very sophisticated. It has cameras on the top, cameras on the side, cameras on the back, and even cameras on the bottom, and also then a big camera right here in front that allows you to take pictures with it. But all these cameras actually allow it to see in all directions, so it does not fly into a tree. And that one will fly over 5 miles, 5.5 miles away. I can control that drone. So it uses electric energy as our example that you see up on the screen. Next form of energy is referred to as radiant or light energy. Write this definition down. This is the energy that electromagnetic waves carry. Copy that from the screen, the italics print. The energy that electromagnetic waves carry is called radiant energy. Now, the sun gives off energy that travels to Earth as electromagnetic waves. Unlike sound waves, electromagnetic waves can travel through a vacuum. Now, when I refer to electromagnetic waves, we're talking about light waves, microwaves, and radio waves. These are all electromagnetic waves. So the sun, yes, we know the sun gives us light, but the sun also gives off microwaves and radio waves. And then, we refer to some of this radiant energy as light energy. But it's really a form of everything in the electromagnetic spectrum. Light, the colors of the rainbow, red, orange, yellow, green, blue, indigo, and violet. These are only small part of radiant energy. There is so much more that human eye cannot see that is light. Some insects can see different forms of energy, and the human eye cannot. We can only see the colors of the rainbow. And then the last form of energy that we need to know is nuclear energy. Write the word nuclear down. I think that's missing in your notes. If the definition is not there, go ahead and write it down. It is the energy that is stored in the nucleus of an atom and then released in that atom. As we studied in our first chapter, chapter 1 of the book, at the center of every atom is a nucleus, and in a nuclear power plant, nuclear energy is released when the nuclei of uranium atoms are split apart. So there's tremendous power in nuclear energy, and nuclear energy is very, very efficient and can give a lot of energy off. However, it is also very, very dangerous. So it's something we need to watch. Our very last note here is analyze it. It says use the term kinetic energy and chemical potential energy to describe the types of energy demonstrated as you eat an apple on your way to class. All right, so let's talk about kinetic energy. So write the word kinetic energy on the first line. What is the form of kinetic energy in this example? Well, it would be you walking to class. So next to the word kinetic energy, write the sentence, I am walking to class. So the motion of the body, anytime I say kinetic energy, you're thinking the motion of something. So the motion of the human body walking down the hallway to class. And then on the next line, write chemical potential energy, and then write down the glucose that is found in the apple. The glucose that is found in the apple. So your body is going to use the glucose from that apple and eventually allow you to walk down the hallway. From the chemical potential energy from the apple is transferred into the energy of motion or kinetic energy of the human body. This now concludes our notes for this first lesson of chapter 2. Hopefully you're keeping up with your notes. If you have not kept up with these notes, you need to go back across Canvas Calendar. I've made all the Canvas assignments available all the way through the month of December. Even though there's a due date on them, you can still go back through any homework assignment that I'm giving you, even if there's a line through it. The line basically means that it's past the due date, but you can still look at that assignment and do those back assignments. Okay, sixth graders, we really need to be paying attention to your missing assignments. I've not given you any assignments here in science the last couple days, just having you take some notes, and that's it. Get on Harmony to see if I've given you any zeros. If I've given you some zeros, you need to figure out what that assignment is, go to Canvas Calendar, find that assignment, do that assignment, and then email it to me right away. You do not want a zero for anything in science. Some of you have not even finished your science test that we gave here the last couple of days ago. You need to get that test done from chapter 4 on the solar system. If you get a zero on that test, you will not pass science in this grading period. We do not know how long we will be virtual. Well, we've not been told as teachers. So we may need to do this for a while. You need to stay up to date on your work. I know it is challenging for some of you, but some of you are not working up to your potential. And I know that you can do much better. All of us teachers are very worried about each of you not doing the work day to day. So keep up with your work each day. Now, those of you that are getting this done, we're very proud of how you're working. We know that you're working very, very hard and that you're getting things submitted to us on time. So keep up that good work, and hopefully you won't have any issues. Keep your iPad charged and ready to go. And if you have any questions or concerns, feel free to email me, and I will try to help you get the problem solved. So let's keep working hard in science, in math, in reading, social studies. Try to get all your work done on time. I'll talk to you later.